Scientists have developed a tiny wind turbine that can scavenge energy from the breeze made while walking. Imagine rubbing a balloon on your hair for a few seconds. Can you hear the crackle of static electricity? See your hair stand on end. That energy, powered by the contact and separation of two materials, can be bottled up and stored for use, according to researchers working on the device. Scientists in China hope the device can generate sustainable power in a low-cost, efficient manner. Once placed on a person's swinging arm, the airflow is enough to generate power, the researchers said. Our goal is to solve the issues that the traditional wind turbines can't solve, said lead author, Dr. Ya Yang, of Beijing Institute of Nanoenergy and Nanosystems, in a statement. Unlike wind turbines that use coils and magnets, where the costs are fixed, we can pick and choose low-cost materials for our device. The device comprises two plastic strips in a tube that flutter or clap together in the presence of airflow. A gentle breeze of 1.6 meters a second is enough to power the device, but it performs best at a speed that ensures the two plastic strips flutter in sync, when wind velocity is between 4 and 8 meters per second, the researchers said. If you like the latest energy-saving technology and knowledge, please follow our channel. The device appears to be a simple, reliable method of generating a small amount of energy that could then be deployed in a variety of ways, such as powering remote sensors, security cameras, or even a weather station on top of a hill that is otherwise difficult to reach, said Richard Cochrane, Associate Professor of Renewable Energy from the University of Exeter, who was not involved in the study. We won't see this innovation replacing the big turbines, but we are seeing increasing numbers of these sort of technologies being used for energy harvesting, providing power in places that are otherwise quite hard to get electricity to. So far, the device has been able to power up 100 LED lights and temperature sensors, its makers said. It also has a wind-to-energy conversion efficiency of 3.23%, which they claim exceeds previously reported performances on wind energy scavenging. In their paper, published in Cell Reports Physical Science, the researchers show the frequency of the oscillation varies with the wind speed exerted on the device, noted Cochrane. But what will be interesting is to see how sensitive the energy output is related to that frequency or the wind speed. Do they need a certain frequency to get any energy out of it? If it's oscillating below 24 Hz, can it still generate energy? Additionally, when something flops back and forward, you get fatigue in the materials. So how long these devices last would be interesting to see, he said. And then how does the technology cope with ice, rain, dust and salty wind blown in from the sea? That would be nice to see proven, because that can be a challenge with conventional turbines. Meanwhile, its makers are dreaming big. They hope to combine it with small electronic devices such as phones, to provide sustainable electric power, and eventually to make the device competitive with traditional wind turbines, where output is heavily dependent on high wind speeds. If you like the latest energy-saving technology and knowledge, please follow our channel.